Waves by Emma and Chris. Different types of waves. So there's transverse waves, which is a wave where the material is pushed up and down or side to side as the pulse is pushed through the medium. Okay, so there's also longitudinal or compressional waves, which is a wave that results when a medium is compressed in a parallel direction to the material. Waves travel through mediums by creating vibrations in the mediums. And there you go.
Three, go. So compressional waves move a bit faster than transversal waves because the energy moves straight through a compressional wave. It was hard to tell in the test we did because the velocity was so close, but it is faster in a compressional wave. And a wave reflects off a fixed end by inverting itself in a transversal wave. And in a compressional wave, it just bounces straight off.
So when waves are reflecting off of a loose end, transversal waves are no longer inverted, meaning that if they had an upward pulse, then it would still be upward in the opposite direction. And for longitudinal waves, they go the opposite direction and the wave still compresses along the medium the other way.
So when there's two different types of wave interference, constructive interference and destructive interference. The first one I'm going to talk about is constructive interference. That's when two waves are traveling at each other with similar amplitudes. So let's say a wave has an amplitude of 2 and there's another wave traveling at it with an amplitude of 1. When those waves hit, the moment that they hit, the amplitude of both those are added together. So then that new wave has an amplitude of 3 just for the moment that they meet, and then they continue on their way. The other type of interference, destructive interference, is when two different waves are traveling at each other with opposite amplitude, and the moment that they hit, the amplitudes subtract from each other. So if it has the same amplitude, it becomes an amplitude of 0 the moment they hit, and then continue on their way, just like the previous one.
Okay, when two waves overlap and one is transverse and the other is longitudinal, what happens is basically the longitudinal pulse, it travels along the transversal pulse. So both are traveling along the medium at the same time.
So the speed of the wave varies with different types of mediums used, such as a rope and a slinky. Both of them have different density, temperature, and elasticity that affects how fast the wave travels through that medium. And the speed of the wave varies with the tension in there. When there's more tension, the wave travels with a greater horizontal speed, but when there's greater tension, it also has less amplitude.